This is the Edexcel higher tier paper 3 calculator paper from June 2023. Question 1. Simplify m squared cubed the quick way. When we've got a bracket with two powers, two indices, we multiply them. So 2 times 3 is 6. It's m to the power of 6. That works because m squared cubed is m squared times m squared times m squared. So we've got 6 m's multiplied together. When we multiply indices, we add the powers, m to the power of 6. Part B, x to the power of 5 times x to the power of 8. When we multiply indices, we add the powers. 5 plus 8 is 13. And part C, expand. So 4p times p squared. P times p squared is p cubed. So that's 4p cubed. And then 4p times 3p. 4 times 3 is 12. P times p is p squared. Question 2. Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups. 10.6 grams of coffee are needed for each cup of coffee. So 2 cups of coffee, 10.6 grams in each. So 2 10.6s. We can use the calculator. That gets us to 21.2. So 21.2 grams per person. And Johnny assumes 68% of the people will drink coffee. So we need to work out 68% of 800. So 68%, that's 68% as a decimal, of times, of means times, or times means of, 800. 68% of 800 is 544. So we've got 21.2 grams per person, 544 people. So 21.2 times 544. And that is 11,532.8. 11,532.8 grams of coffee. Give your answer correctly the nearest gram. So 11,533 grams of coffee. Johnny's assumption is wrong. 72% of people will drink coffee. How does this affect your answer to part A? Well, we had 68%. Now we've got 72%. So it's going to be bigger. He's going to need more coffee. So he will need more coffee. Question 3. ACF and ADG are straight lines. BCD and EFG are parallel lines. So we've got 2 parallel lines here. Show that triangle ACD, that's this top triangle here, is isosceles. So 2 angles are going to be the same for it to be isosceles. And we just need to work out the angles in this triangle at the top. So let's start with angles on a straight line. So we've got 70 degrees here, 180, take away 110 is 70 degrees. And it says give a reason for each stage of your working. So every time we work something out, give the reason. So angles on a straight line. Let's use the parallel lines now. So 125 degrees here. The same angle on the other parallel line is called a corresponding angle. So it's exactly the same angle. So we've got 2 parallel lines, a line going through them. So this angle here will be the same as this one here. It's the same angle on the other parallel line. They're called corresponding angles. So corresponding angles are equal. Then we can use angles in a straight line again. So 180 take away 125 this time, which is 55 degrees. So again, angles on a straight line. And finally, angles in a triangle for the top one. So 70 and 55 make 125. So that means the other one is 55 as well. Angles in a triangle. So 180, take away 70 and take away 55 makes another 55-degree angle. So we can see that ACD has got two 55-degree angles, so two angles the same. Therefore, isosceles. Question 4. It takes 14 hours for 5 identical pumps to fill a water tank. How many hours will it take for 4 of these pumps to fill another water tank of the same size? So it's inverse proportion. The more pumps we have, the less time it takes. So if we double the number of pumps, we halve the amount of time it takes to fill up the tank. If we do 14 times 5, we get 70. So that tells us it'll take 70 hours of work in total. 70 hours for one pump. So we need 70 hours of pump working to fill up this water tank. So if we've got 4 pumps, we can split that work between the 4 pumps. 70 divided by 4 is 17.5. And we can see it takes more time because we've got less pumps. We've got 4 pumps, so it takes longer to fill up the tank. Question 5. A and B are numbers such that, and we're given A and B as a product of their prime factors. And we need to find the highest common factor, and for part B, the lowest common multiple. So some of the work's been done for us. We've already got them written as a product of their prime factors. So I'm going to put them into a Venn diagram. The numbers in common, the prime factors in common, I'm going to put in the middle. So they've both got 2 3s and a 7 in common. A has got 2 2s and 2 more 3s, and B has got another 7. And the highest common factor is the numbers in the middle multiplied together. So 3 times 3 times 7, which is 63. And the lowest common multiple is all of the numbers multiplied together. So 2 times 2 times 3 4 3s multiplied together, and 2 7s multiplied together. All of these numbers multiplied together and that is 15,876. Question 6. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? Give your answer correct to the nearest day. So we can work out how many seconds it takes by dividing the amount of lava we've got by 11.9. Because 11.9 meters cubed come out every second. So we'll take our number and divide it by 11.9 to find out how many seconds it takes. And then it's just going to be a case of converting seconds into days. So we've got 5647, so 5,647,529. So that is our seconds. That's how many seconds it takes. So if I want to change that into minutes, I'm going to divide it by 60. So I'm going to get my number of seconds, divide it by 60, using the whole number in the calculator. Don't round it too soon. So that's minutes. And again, if I want to change minutes into hours, I'm going to divide it by 60. So I've got 94,000 minutes. Divide it by 60, and that will tell me how many hours I've got. Again, using the whole number from the calculator. So 1,568 point something hours. And then changing hours into days. There are 24 hours in every day. So divide the number of hours by 24, and we get 65.36 days. And to the nearest day, 65. Question 7. Here's a graph. Write down the coordinates of the turning point. So the turning point is where it turns. It's at 1, -3. Write down an estimate for one of the routes. So we've got the graph. The routes are here where it crosses the x-axis. And we only need to write down one of them. So they are at minus 0.7 and 2.7, either one for the answer, because they're both roots of the equation. Question 8. A solid cuboid is made of metal. It's got a density of 9 grams per centimeter cubed, a volume of 72 centimeter cubed. What's the mass? So density is equal to mass divided by volume. If we want to rearrange this to get mass by itself, to get rid of a divide, we times. So it's mass equals density times volume. So to work out the mass, we get the density and we multiply it by the volume. 648. So 648 grams is our answer. Question 9. Some people were asked if they wanted a new television. 70% said yes. 80% of the people who said yes wanted a television with a large screen. What percentage of the people said they wanted a television with a large screen? So 70% of people said yes, and 80% of them wanted a large screen. So we want 80% of 70. So 80% of 70%, 70. So 0.8 times 70. So of is times 80% as a decimal is 0.8. So 0.8 times 70 is 56. So it's 56%. You could think of this as a probability tree if you wanted. So it's, do you want a new television? Yes and no. Do you want a large screen? Yes and no. So this is 0.7, 0.3, 0.8, 0.2. So if you want yes, yes, it's 0.7 times 0.8, which would be 0.56. And as a percentage, 56%. Question 10. ABD, the whole shape is a triangle. C is a point on BD, so we're splitting it into two separate triangles. Work out the length of DC. So this part here. So we're going to use SOHCAHTOA twice. So we're going to find AC first. So that'd be the opposite and the hypotenuse. So that's SOH, that's sine. So we're using SOH, sine with the angle equals O, the opposite, divided by the hypotenuse, which is 6.8. To get the opposite by itself, to get rid of a divide, we times. So it's going to be 6.8 times sine 41 to find that opposite. 6.8 times sine 41 is 4.46. So now we know that this is 4.46, and now that is the opposite. This is the adjacent, so it's TOA for the second one. Tan with the angle 55 equals O, which is our unknown. No, it's not. O is 4.46 over A, which is our unknown. So we times by X to get rid of the fraction. X times tan 55 equals 4.46. Then divide by tan 55 to get X by itself. So again, we'll use the whole number in the calculator and divide it by tan 55. So we get 3.12. To one decimal place, say 3.1. Question 11. The table shows some information about the heights of a group of adults. And we're going to draw a box plot. We've got the lowest, the biggest, the median, the lower quartile, and the upper quartile. That is exactly the information we need. And we need to be careful with the scale. It's going up in every 2 is 1. So every 2 little boxes represents 1. So 169, we'll draw a line. So 2 back from 170. 186. 177 for the median. 174 lower quartile, and 180 for the upper quartile. So a box around the quartiles and lines out to the highest and lowest. So that is our box plot. And then we've got a box plot for a group of teenagers, and we need to compare the distribution of the heights of adults with the heights of teenagers. So we need to compare the median. So we can say the median is greater for the adults. And be careful to say it in context. So we have to say the median height. We can't just say the median is bigger. We need to say it in context of the question. So the median, so the word height would be absolutely fine for context. The median height is greater for adults. So that's 1 point. We've got the median. Now we need to compare the spread. So we can either compare the range, the biggest take away the smallest, or the interquartile range, the upper quartile take away the lower quartile. So the interquartile range is the same for both groups. So the interquartile range. And then if you want this one in context, is the same for the heights of both groups. Only one of them actually has to be in context to get the 2 marks. So we have to compare the median, compare the spread, and one of the comments needs to be in context to get the 4 marks. Question 12. Show that x minus 1 times x plus 3 times x minus 5 can be written in the form, so expanded and simplified. So expanding triple brackets, we start by expanding just 2 of them. So let's expand the first 2. X times x is x squared. X times 3 is 3x. Negative 1 times x is minus 1x. And negative 1 times negative 3 is negative 3. We can simplify that expansion. So 3x's take away 1x is 2x. And then we're going to expand again. So we're going to expand by multiplying each of the terms in the first bracket by both of the terms in the second bracket. Exactly how we expanded before. Both of the terms in the first bracket we times by both of the terms in the second bracket. This time all 3 of the terms in the first bracket we multiply by both of the terms in the second bracket. So x squared times x, x cubed, x squared times negative 5, negative 5, x squared. So that's the x done, the x squared done even. Then we move on to the 2x. So 2x times x, 2x squared, 2x times negative 5, minus 10x. And then the negative 3 times x, negative 3x. Negative 3 times negative 5 is positive, and 3 5s are 15. Then we can just collect the like terms. So we've got 1x cubed. We've got negative 5 plus 2, so negative 3x squared. We've got negative 10, take away 3, negative 13x, and we've got a plus 15 on the end. Question 13. An expression for the nth term of the sequence of triangular numbers is n times n plus 1 over 2. Prove that the sum of any 2 consecutive triangular numbers is a square number. So if we have a number we're putting in here, let's call it m. The next number, the one after it, is going to be m plus 1. So our 2 consecutive numbers we can call m and m plus 1. And we want the sum of them. So we substitute m in, substitute m plus 1 in, and add them together. So that'll be the sum of 2 consecutive triangular numbers. So if I substitute m in, it'll be m times m plus 1 over 2. And for m plus 1, changing n into m plus 1, it'll be m plus 1 times m plus 1 plus 1, so m plus 2 over 2. And I think I'll expand the tops. So I've got m squared plus m over 2. And I've got m squared plus 2m plus m plus 2 over 2. I'm going to make them into one fraction. A bit concerned about the space I've got here. So add the tops and the bottom stays as 2 because we've got a common denominator. So just like we'd add 1/4 and 2/4, the bottom stays the same and we just add the numerators. So I'm going to move to the side here to carry on working out. So I'm just going to simplify the top line. So m squared and m squared is 2m squared. I've got m, 2m and m. So I've got 4m and I've got 2 over 2. So I can half it. I can half each term. So I've got m squared plus 2m plus 1. That is simplified. I need to prove that it's a square number. How can I show it's a square number? Well, I can factorize it. So it factorizes into m plus 1 times m plus 1, which is the same as m plus 1 squared. And because it's something squared, it's a square number. So it's always going to give out, no matter what number I put in for m here, it will always be a square number because we're squaring it. Question 14. OAB is a triangle. OBC is a sector of circle center O. Calculate the area of the sector OBC. Give your answer to 3 significant figures. So 2 parts to the question. We can use the cosine rule to find the radius. And then once we've got the radius, we can find the area of the sector because we know all the information we need. So the cosine rule says that a squared equals b squared plus c squared minus 2bc cos a. So big A is our angle, little a is opposite big A, and the other 2 lengths, either way round, are called b and c. So let's substitute in. So we've got a squared equals 9 squared plus 6 squared minus 2 times 9 times 6 times cos 35. And we can just type this into the calculator. 9 squared plus 6 squared minus 2 times 9 times 6 cos 35. So this will be a squared, 28.53. So square root it. And we get 5.34. And that is our radius. So that's the radius. The area of a sector, so the area of a circle is pi r squared. And what fraction of the circle have we got? We've got 80 degrees. 80 degrees out of 360 in total. So we want 80 360ths of pi r squared. So 80 360ths of pi times 5.34 squared. So again, we'll just type this into the calculator. We can use the whole number for a, so we don't have to round it. So it's 80 over 360 times pi times the answer squared. So we get 19.9. So that is our answer, 19.9 centimeters squared. Question 15, factorize. So we are using the difference of 2 squares here. So we've got 2 things squared with a minus between them, a bit like x squared minus 25. So this one is a plus b times a minus b. Show that 2 to the power of 40 minus 1, so part B, there's a link between the 2 questions, is a product of 2 consecutive odd numbers. So again, we've got the difference of 2 squares. So 2 to the power of 20 squared is 2 to the power of 40. So it's 2 to the power of 20 plus 1 times 2 to the power of 20 minus 1. So how can we say it's the product of two consecutive odd numbers? So 2 to the power of 20 must be even. It's a multiple of 2. So the two numbers either side of it must be consecutive odd numbers. So 2 to the power of 20 plus 1 and 2 to the power of 20 minus 1 must be consecutive odd numbers. Question 16. On the grid, enlarge triangle T by scale factor -2 with centre of enlargement -2, -2. So here's the centre of enlargement, -2, -2. So the distance from each point is going to be multiplied by -2. So at the moment, to get to this red point, we're going back 1, 2, 3, 4. You could say it's a translation to go to that point of -4, 0. So if you times that by -2, what do you get? You get 8, 0. So 8 to the right and nothing up and down. So that point moves there. This green point, it's back 1, 2, 3 and down 1, 2, 3. So -3, -3 times it by -2 will get us to 6, 6. So 6, 1, 2, 3, 4, 5, 6 to the right and 6 up. And this blue point, 1, 2, 3, 4, 5, 1, 2, 3. So back 5, down 3, times it by -2 will be 10, 6. So 10 to the right, and then 6 up. And we can join these points up with our ruler. And there is our new triangle. We can check that each of the points, if I join them up red to red, it goes through the center, green to green goes through the center, and blue to blue goes through the center. Question 17. Here is a distance time graph. Find an estimate for the gradient of the graph at 2.5 seconds. So 2.5 seconds is here. To find an estimate for a gradient on a curve, we have to draw a tangent. So a straight line that just touches the, I'm going to move that, just touches the curve at that point. So something like that. And we work out the gradient of it by doing the change in the y. So gradient is always change in y divided by the change in the x. So let's find some good points if we can. Quite hard to see a good point. So let's go with 1.40. And we could go with 2.5, 20. Or we could go up here, 4.5, 57 or something. It doesn't matter. 2.5, 20. So the change in the y's. So 20 take away nothing. 20 take away nothing. Change in the x's. 2.5 take away 1.4. So it's 20 over 1.1. There'll be a range of acceptable answers. I've got 18.18 and so on. But 18.2. There'll be a range of acceptable answers. Everyone's tangent will be slightly different, but something in that area. What does the gradient of the graph represent? So we did the change in y over the change in x. So it's change in distance over change in time. So what is distance over time? That is speed. So it's the speed of just speed. Question 18. A solid frustum is made by removing a small cone, from a large cone, as shown in the diagram. The slant height of the small cone is 6. The slant height of the large cone is 10. So we can straight away work out a scale factor between them, which we're probably going to be using. So let's just work that out. So we've got a big and a small cone. So we had 6 and 10. So what is the scale factor? So to go from 6 to 10, we multiply. To go from 10 to 6, we multiply by 6/10, 0.6. And to go back the other way, we'll divide by 0.6. The radius of the base of the large cone is 3. So if we've got 3 for the large cone, 3 times 0.6 is 1.8 centimeters. So for the small cone, it's 1.8 radius. Calculate the total surface area of the frustum. So we're going to do the surface area of big cone, curved surface area of big cone, take away curved surface area of small cone, and then add on the two circles, the top and the bottom. So we've got curved surface area. Let's do big. So it's pi RL, pi times 3 times 10, 30 pi. And then curved surface area again, but for small. So pi times 1.8 times 6 this time. So 10.8 pi. So 30 pi, take away 10.8 pi is 19.2 pi. Then we have the circle at the bottom. So area of a circle is pi r squared. So pi times 3 squared, which would be 9 pi. And we've got pi times 1.8 squared for the top circle. Which is 81 over 25 pi. So we just need to add all this together. So we've got the big surface area, the big cone, take away the small cone, which was 19.2 pi. Then add on the big circle and add on the small circle. So it's this one plus 9 pi plus 19.2 pi. And we get to 3 significant figures, 98.8. 98.8 centimeters squared. Question 19. Sana needs to draw the graph of y equals 3 to the power of x between 0 and 4. The x values between 0 and 4. She draws the graph. Write down one thing Sana has done wrong. So the graph should be intersecting here at 1. So any of these graphs, exponential graphs, 2 to the power of x, 3 to the power of x, they all take the same shape. They cross at 1. And this graph doesn't. It crosses at 0. So it should start at 0, 1. Question 20. Prove algebraically that 0.123 recurring, just a 2, 3 recurring, 2, 3, 2, 3, 2, 3, and so on. So 0.123, 2, 3, 2, 3, and so on, can be written as 61 over 495. So let's take our 0.123 recurring and call it x. Make sure in this question we're using recurring notation. So don't leave out these two dots over the 2 and the 3. The alternative would be to write it like this, with dots showing it's going on after. I'm going to find two things that end in the 2, 3 recurring. So if I multiply this by 10, I get 1.23, 23, 23, 23, and so on. And then if I multiply by 100, so multiply the 10 by 100, so that will take it up to 1,000 lots of x. Multiply the original one by 1,000, I get 123.23 recurring. 100x would have been no good to me. That would have been 12.323232. But I want 232323. They need to end in the same thing. So now I've got two things that end in the same thing. I can take them away from each other. So 1,000 x's take away 10 x's. 1,000 take away 10 is 990. And that is 123.23 recurring. Take away 1.23 recurring. The recurring bits cancel out. So it's just 123 take away 1, which is 122. I can get x by itself by dividing both sides by 990. And then half the top, half the bottom, and we have our answer. Question 21, solve. So we've got algebraic fractions. We want to, let's add the fractions together first. To add fractions, we need the denominators to be the same. So I'm going to multiply top and bottom of the first one by 2 minus 2x. And I'm going to multiply top and bottom of the second one by x plus 4. So now I've got two fractions I can add together. They've got the same denominator. They're both x plus 4 times 2 minus 2x. So I can write it as 2 minus 2x plus 3 times x plus 4 equals 1. I can get rid of the fraction now. To get rid of the divide, we times. So times both sides by this denominator. And then expand the brackets and simplify as much as we can. So 3 times x is 3x. 3 4s are 12. X times 2 is 2x. X times negative 2x, negative 2x squared. 4 2s are 8. And 4 negative 2x's are negative 8x. Simplify what we can. So 2 and 12 make 14. Negative 2x plus 3x is 1x. Then we've got negative 2x squared. 2x take away 8x is negative 6x. And we've got an 8. I'm going to move everything over to the left side to make my x squared positive. So plus 2x squared. I'm going to plus 6x to both sides. So that'll be 1x plus 6x is 7x. And take 8 away from both sides. So I've got 2x squared plus 7x's plus 6 equals 0. So we've got a quadratic to solve. We're in a calculator paper, so we could use the quadratic formula, or we could try and factorize it. If it doesn't factorize, we'll have to use the quadratic formula, but let's give it a go. So I'm going to do a times c, 2 times 6 makes 12. What multiplies to make 12 and adds to make 7. So if we can find something, we'll be able to factorize it. So it's not 1 and 12, it's not 2 and 6, but 3 and 4 work. So I can rewrite it, rewrite the 7x as 3x plus 4x. So I know I can factorize it. So what's common to the first two terms? What comes out the first two terms? Just an x. X times something is 2x squared. That must be 2x. X times something is 3x. That's a 3. Something times 2x is 4x. That's a 2. And 2 3s are 6. So x is equal. What makes the first bracket 0? Negative 2. What makes the second bracket 0? It's minus 1.5, or minus 3 over 2. Question 22. Given that the vector a times 2, 6 plus b times 8, 2 is parallel to the vector 13, 6, find an expression for b in terms of a. So if it's parallel to this vector, that means it's some multiple of that vector. So we can say that a times 2, 6 plus b times 8, 2 is something times 13, 6. And if they are equal, if this is an equation, the x's should be equal and the y's should be equal. So we can split these off into two separate equations. So let's have 2a plus 8b equals 13k, and 6a for the y's plus 2b equals 6k. So we split them off. Then we need to get rid of the k's. So the best thing to do is going to be to divide the top one by 13, divide the bottom one by 6, so they're both k equals. So if we have 2/13 a plus 8/13 b is equal to k, and we'll have divided by 6, so 6 over 6 is 1, so just a plus 2 over 6, a third, b is also equal to k. Then they're both k equals, so we can make them equal to each other. So I can say 2/13 of a plus 8/13 of b equals a plus 1/3 b. So all we need to do now is find an expression for b in terms of a. We need to make it b equals. So doesn't really matter which way around we do it. Let's take the 1/3 b away from 8/13. So 8/13 minus 1/3 is 11/39. So that's 11/39 b. And let's take 2/13 a away from both sides. So 1 minus 2/13 is 11/13 equals 11/13 of a. So I've just taken a third b away from both sides and 2/13 a away from both sides. We just need to get b by itself. So to get rid of, I can do it in 2 steps. I could times by 39 and then divide by 11. Or actually, I'll just divide both sides by 11 and have 1/39 b equals 1/13 a. And then times both sides by 39. So 39 over 13 is actually going to be 3. So b equals 3a. And that is our answer. Question 23. A circle has equation x squared plus y squared equals 25. So that is a circle. The center's at 0, center's at the origin, and it's got a radius of 5. So it's like 5, minus 5, 5, minus 5. The point with coordinates -3, 4 lies on the circle. Alex says that the tangent at P, -3, 4, crosses the x-axis at -8, 0. So down there. Is Alex correct? You must show how you get your answer. So there's a few ways of doing this. We can, the usual way, one with the more common question, is to work out the equation, the gradient of the, work out the gradient of the radius, use perpendicular lines to work out the equation, the gradient, and then the equation of the tangent, and then we'll see where it crosses the x-axis. We'll do it that way because it's a more common question. So we've got -3, 4 here, and then we've got 0, 0 here. So what is the gradient of this radius? So it's the change in y over the change in x. So the gradient is the change in y, so that's 4 take away 0, over the change in x, -3 take away 0, which is -4/3. So the perpendicular gradient, the gradient of the tangent, is a negative reciprocal of -4/3, flip a -3/4. So we know the gradient, and we know it goes through -3, 4. So we can use that to find the equation, y equals mx plus c. So we know m is 3/4, so y equals 3/4 x plus c, and then we can substitute in -3 and 4 for x and y to find c. So if 4 equals 3/4 times -3 plus c. So 4 equals -9/4 plus c, plus 9/4 to both sides. 4 plus 9/4 is 25 over 4, or 6.25. So c is, I'll do 6.25. So I've got the equation of the tangent, y equals 3/4 x plus 6.25. So that's the equation of this tangent. If I want to know where it crosses the x-axis, it crosses x when y equals 0. We know it's something 0. It's something 0. So if I make y equal to 0, I can find out what the x coordinate is. So take away 6.25 from both sides. And then, so I've got -6.25 equals 0.75x. Divide both sides by 0.75. And I get -8.3 recurring. So is Alex correct? He said it was negative 80. No, it is minus 8.3 recurring 0. And finally, question 24. There's a total of Y counters in a box, X pink, 5 blue, and the rest green. So there's pink, X pink, 5 are blue, and the rest are green. The ratio of X to Y is 1 to 3. So we've got X to Y 1 to 3. Reader takes at random 2 counters from the box. Find in terms of X, an expression for the probability Fraser takes 2 counters of the same color. So we want the probability of 2 pink, pink, the probability of blue, blue, and the probability of green, green. And we want it just in terms of X, so we don't want any Y's. So we can use this ratio to put everything in terms of X. So the ratio of X to Y is 1 to 3. And I like to just cross these over. So Y times 1 equals X times 3. So Y equals 3X. So if the ratio of X to Y is 1 to 3, that means the total number of counters in the bag is 3X. So total is 3X. So not Y, 3X. And then how many green are there? So for green, it's 3X minus X minus 5. So the total, take away the blues, take away the pinks, must be the greens. So 2X minus 5. So we've got all the information we need now. Now we can just do the algebra part. So the probability of pink, then pink. So it's X over 3X for the first one. For the second one, if we've removed the counter, there's going to be 1 less pink and 1 less in total. So X over 3X times X minus 1 times 3X minus 1. For blue, blue, it's going to be 5 out of 3X for the first one. And the second one, for another blue, there'll be 4 blues left out of 3X minus 1 in total. And green, green, there were 2X minus 5 to start out of 3X. If we remove 1, there's 1 less, so 2X minus 5 minus 1 is 2X minus 6 out of 3X minus 1 in total. So we can either have pink, pink, blue, blue, or green, green. So we need to add these together. It's going to be a lot of algebra, just simplifying all of this. So we're going to have X times X minus 1 over 3X times 3X minus 1. Or we could have 5 times 4, 20, over 3X times 3X minus 1. Or we could have 2X minus 5 times 2X minus 6 over 3X times 3X minus 1. So we need to expand these brackets. We can make it into one fraction though first. So it's going to be 3X times 3X minus 1 on the bottom. And then we just need to, for the sake of space, I'm going to expand them as I go. So X times X is X squared. X times negative 1 is minus X. We've got plus 20 plus 2X times 2X, 4X squared. 2X times negative 6, negative 12X. negative 5 times 2x, negative 10x, and negative 5 times negative 6 plus 30. So we have 5x squared, x squared, x squared. For x's, we've got minus 1, minus 12, so minus 13, minus 10, minus 23 x's, and we've got plus 50, and on the bottom 3x times 3x, 9x squared, 3x times negative 1 minus 3x. So it's in the form we wanted it. We don't have to do anything more. That is our answer.